So for this video, we're going to be continuing with the topic on sets in chapter 2 for the ZIMSEC O-level maths syllabus. So part of this video is mostly going to be looking at Venn diagrams and the calculations that are involved. The first question says a survey of 100 families. So we can be highlighting the key points. So it's 100 families showed that 32 had a TV set, 51 had a gas cooker, 40 had neither. How many had both? So just sketching out the general information that we had. So we know that the number in the universal set is 100. The number who had a TV, that was 32. The number who had a gas cooker, just going to call it GC for notation's sake, that they were 51. And then the number of those who had neither was 40. And we're trying to find the number who had both a TV set and a gas cooker. So let's call that number X, right? So the first thing we have to do is we have to represent this in a Venn diagram. So we are going to plot it out. And in this case, we have two things that are happening. Whether you had a TV or you had a gas cooker, or you had neither, or you had both. So, so we have the universal set at large. Then we have TV here, and we have a gas cooker right there. So what we do not know is the X, those who had both. But what that means is the 32 who had a TV included those that had both. So that means we have to write 32 minus X, right? Because if we're going to count people who had TV, we're already including the ones that were that had both the TV and the gas. Same as the 51 who had the gas cooker. They had both. Some of them had both and some of them did not have both. They only had the gas cooker. So 51 minus X. And then neither, just in the universal set, we have 40. So what we now do is we know that at the end of the day, we have 100 families. And this whole subset is supposed to represent 100 families. So if we add people who had TV, which are going to be 32 minus X, which are TV only, plus those who had both, which is X, plus those who had gas cooker only, which is 51 minus X, plus those who had neither, which is 40, we should get 100, right? And when we expand this, we know that 100 will be equal to 32 minus X plus 51 minus X plus 40, right? Which is going to be 100 is equal to, and when you compute this, you end up with, we're going to say 32 plus 51 plus 40, that gives us 123. And then we then go with minus X plus X, that's 0. Then we're left with minus X right there. So we have 100 is equal to 123 minus X. When we rearrange this equation such that the X crosses the equal sign, it becomes X is equal to the 100 crosses the equal sign, 123 minus the 100. And then X is equal to 23. So 23 had both. You can always cross-check this by rewriting the equation or representing again the Venn diagram if you have extra time, or if you just want to confirm that what you got is represented by the answer that you got. So again, it should always add up to 100. So we had TV, we had gas cooker, and we had the universal set. So we had 40 had neither. We had 32 minus 23, because now we know what X is. 23, we have 51 minus 23. So I've just taken this Venn diagram and put 23 where X is, because now we have found that, right? Because this is part of the proof. So adding this up, we know that 32 minus 23, that's going to be 9 plus 23 plus 28 from 51 minus 23 plus 40. And when you add these up, you are going to get 100, which means that it is correct that you actually have x is 23. Okay, great. The next question says, in a group of students, in a group of students, 18 play football. So just take note of what they say. 18 play football, 19 play basketball, and 16 play volleyball. 6 play football only. So take note of only. 9 play basketball only. 5 play football and basketball only. 2 play basketball and volleyball only. So when they say 2 play basketball and volleyball only, that means that that's an intersection between volleyball and basketball. So taking down the information that we have, and the first of it all, just the general numbers, we know that the total number of students who play football is 18. The total number of students who play basketball is 19. The total number of students who play volleyball is 16. But then we're told that number of football only is 6 and the number of basketball only is 9. And then we're told that number of football and basketball only is 5. So understand that when they say 2 of the sets and they add only, it's an intersection. That's why here I wrote F intersection B, football intersection basketball, right? And then we have number of those who play basketball and volleyball only, that is equal to 2. So now we have to represent this in a Venn diagram, understanding that in this Venn diagram we have 3 spots. So we're going to have 3 sets. We're going to have football, we're going to have basketball, and we're going to have volleyball. And these at some point are going to intersect. So we have football, we have basketball, and we have volleyball. So you know that football only is 6. Maybe let me use a different. So football only is 6. Basketball only is 9. Football and basketball is 5. Basketball and volleyball is 2. So that's this intersection because we have basketball and volleyball. We were not told how many play everything. We're not told how many play football and volleyball only. Right. The next question says, how many play all 3 games? Right. So we're trying to find x, right? Number for all 3 games. I'm trying to find the intersection of football, basketball, and volleyball. So to find this, we know that we can start with a spot that we have a lot of details for already. When we look at basketball, we already know that we have everything for basketball except for x. Yet we know that the number of students who play basketball is 19. And 19 is then supposed to be equal to 9 plus 5 plus x plus 2. Because when you look at it, that's what is represented, like around basketball, right? We have 5 who play football and basketball, 9 who play basketball only, 2 who play basketball and volleyball, and x who play everything. So that's why we chose basketball, because we have most of the information and fewer unknowns. So 19 is therefore going to be equal to 9 plus 5, that's 14, plus 2, that's 16, plus x. X will be equal to 19 minus 16. X will be equal to 3. So 3 play all the spot. So reconstructing the Venn diagram, we are going to have One more information. So we have football, basketball, and volleyball. So we have 6 there, 5 there, 3 there. We still do not know how many play football and volleyball. We have 2 there and we have 9 there. We also don't know yet how many play volleyball only. So maybe we put this as a Z right here as well. So the next question says football and volleyball only. So football and volleyball only, which is the Y. So again, so football intersection volleyball. That's what football and volleyball only means, which is Y, right? So looking at what we know in that region, in the region of football and volleyball, we know how many play football in total, right? Number of those who play football in total, we were told that it's going to be 18, right? So 18 should be equal to 6 plus 5 plus 3 plus y. So just to check, it's the 6 plus 5 plus 3 plus the y. So 18 will be equal to 6 plus 5, that is 11 plus 3, that is 14. So 14 plus y. Y will be 18 minus 14, so y will be equal to 4. So 4 is the number of those who play football and volleyball. So again, representing this, we have our sets. We have basketball. I'm sorry, I'm gonna start with football. We have basketball and we have volleyball. So looking at it again, we have 6. Now we know this is 4. We have calculated this to be 3. This is 5. This is 9 and this is 2. Perfect. See how we're filling the set, starting with the easier stuff going on. Now we need to know how many play volleyball only. Oof. Okay, great. So that's part C. Is it part C? Yes, volleyball only. Number of volleyball only. Great. When we look at it, we have the total number of people who play volleyball, right? Number for volleyball, we are told, oh sorry, and this is the Z we're trying to find. So we know that the number for volleyball, the total number for volleyball is 16. So we know that 16 should be equal to 4 plus 3 plus 2 plus Z, right? Again, this is the 4, that's the 3, that's the 2, that's the Z. Because we're looking at volleyball only, we're looking at this subset. Great. So when we look at that, expanding that, 16 will be equal to 4 plus 3, that's 7 plus 2, that's 9. 9 plus Z is equal to 16. So Z is going to be 16 minus 9, and that is 7. So that's how many play volleyball only. So again, representing that once more in a Venn diagram. We have football, we have basketball, and we have volleyball. And that is perfect. All right, and then the next part, it says if 8 play no games at all, how many students are there altogether? So now we're told new information that to this diagram, to this universal set, we have 8 who do not play any of the sport. So then the total number of students now has to account for everybody, right? So it's the 8 who do not play anything, 6 who play football only, 4 who play volleyball and football, 5 who play football and basketball, 3 who play all, 9 who play basketball only, and 2 who play volleyball and basketball. And when we add this up, we get 44. So that is the answer. Then we get to the next question. It says, in the Venn diagram, the universal set are students at a school. C are the students who play chess. T are students who play tennis. V are students who play volleyball. How many students play volleyball? Great. So we're going to start with E. Right. Number of students who play volleyball. So again, looking at what that represents is this part of the Venn diagram, right? So that's going to be 6 plus 4 plus 12 plus 41. And when you add that up, you're going to get 63. That's how many students play volleyball. Okay, it says, how many students play both tennis and chess? Number of students who are in the intersection of tennis and chess. Great. So when we look at this again, so we want tennis and chess. So the intersection is this right here. That's the intersection of tennis and chess, which is going to be 7 plus 6, and that is 13. Perfect. And then we go to G. It says, how many students play all 3 games? So going back to our Venn diagram, say all 3 games is the intersection between the 3, which is just 6 students, right? So this one is quite easy sometimes because it's mostly about reading the information in the Venn diagram, or at least interpreting it. So you have to understand what they mean when they say both or when they say or. Is it a union? Is it an intersection? How many students play tennis and volleyball but not chess? So that part is important. So we want tennis and volleyball but not chess. So now we have to highlight tennis and volleyball without highlighting chess. So that's this part. Right, so that's the number who play tennis and volleyball. Yeah, sorry. So it's just it just speaks to the intersection of tennis and volleyball. Sorry, it doesn't include all of them. So it tells tennis and volleyball but not chess, which means it should not include the 6 because that includes chess. So that's just going to be equal to 12. And then I, how many students are there at this school? Number of all students. Be careful not to repeat any particular one. So looking back at it, we have 5 who do not play anything, 41 who play volleyball only, 4 who play chess and volleyball, 21 who play chess only, 7 who play tennis and chess, 36 who play tennis only, 12 who play tennis and volleyball, and 6 who play all 3 sports. So putting that down, we have to add them up. So we have 36 plus 12 plus 7 plus 6 plus 21 plus 4 plus 41 plus 5. Taking note to remember the 5, right? Those who do not play, because that includes everyone at the school. When you add this up, you get 132. And that is your answer. So as practice, please try the following exercise. Where the first one almost deals with what we had done before, understanding complements and unions and intersection. The second one, you have to then draw the Venn diagram yourself and then calculate. And the third one as well. Excuse me. And the fourth one too. And knowing how to represent the different Venn diagram notations, including 2 or 3 sets that are involved. So yeah, if you have any questions, feel free to reach out. Also feel free to take screenshots, pause the video, and capture the questions and give them a try.